from this video, so we are going to do a microservice with from end to end full development. That means a full software life cycle. So before starting into our POC, so let's check high level flow and some services about something like AKS, Azure services. So first we will check what is that, and then we will move forward step by step. This is the high level flow. So first step, we are going to push our code to GitHub, and we are going to make 3 independent microservices: product service, order service, and notification service. Each service has its own API, owns its own database, has health endpoints, and then we are going to make a CI/CD pipeline using GitHub Actions. So we are going to push the code. GitHub Actions detect which service changed, and only that service pipeline runs and restores, builds, and tests. This is the flowchart example. So we are going to push the code, and we have 3 services: product service, order service, notification service, and so each has its database and each has its own health endpoints. And then GitHub has CI/CD pipeline, GitHub Actions. We are going to use that. So using this GitHub Actions continuous integration, we are going to restore the project, build the project, and test the project for each services. And we are going to use Docker as well, step by step. Next one, we have a CI/CD in our GitHub action. So Docker images, we are going to create Docker images for each service, and then we are going to make it with Azure Container Registry. So why we need a So what actually happens? So each service has its own Docker file, because each microservice is independent, can be built, deployed, and scaled separately, and CI builds Docker images automatically when you push code. So we are pushing the code, and CI pipeline does like .NET build, .NET test, and build. So no manual builds, not we are doing, and same process every time. So no works on my machine issue like that. And secure non-root Docker image. So like app runs as non-root user, smaller base images, app ASP.NET runtime only. So why we need inside Docker file? Why we need this one Docker image? So it will be help us for better security and less attack surface, and images will be versioned like this. For each build, it creates a new immutable image. So versions usually comes from git tag, build number, and release version. So we are going to make a version, just keep that in mind. As of now, we are going to make versions somehow in our GitHub images, each build. And the images will be pushed to Azure ACR. Azure Container Service. So ACR becomes your single source of truth that for deployable artifacts. So why this approach is powerful? Immutable deployments. Once an image is built, so you never modify it, you only deploy it. You are not going to modify after creating the image. and you need a change like build a new image. So this avoids hidden charge changes and environment different and manual fix on server like that. Same image across the dev, test and production. So only configuration will changes. So result will be like fewer production surprises, true environment parity. So we can run the same thing even all environments, dev, test and production, only the database and other configuration will change there. And in case of production issue, so just redeploy the previous versions. So no rebuild, no hotfix, no panic. So rollback means configuration change, not deployment work. Interview ready explanation. CI/CD builds versions Docker images for each microservice and pushes them to Azure Container Registry. So these immutable images are deployed consistently across environments, making deployments predictable and rollback fast and safe. So this is what we are doing. We are pushing the Docker images to Azure Container Registry. So there we are going to keep our Docker image with versions. Infrastructure provisioning with Terraform. So in this space what we are going to do, so Terraform creates shared infrastructure for AKS cluster, ACR, databases and service bus, Azure service bus, log analytics, and everything is repeatable and version controlled, so that no manual infrastructure different and environments are consistent and easy to recreate in disaster, that means in rollback scenarios like that. So outcome, infrastructure as code. So we will just have code, then we can easily create services, no need manual clicks in Azure portal. So what happens here? Infrastructure provisioning. So this is the step, who creates Azure resources and how do we control them. So using Terraform, what happens? Terraform uses TF files code, that means .tf files code to create Azure infrastructure automatically. Instead of clicking Azure portal, we just write it. So what Terraform creates? Shared infrastructure. So AKS host all microservices, handles scaling and networking, rolling updates. So one cluster, many services, and then Azure Container Registry stores versioned Docker image and secure access from AKS. And AKS pulls images directly from ACR. And databases, example product order user. So we will have separate DB for true microservices and independent scaling and schema changes, and then it will create service bus with async communication for better services, event driven architecture. And logs, we need centralized logs, metrics, and AKS app logs, infrastructure logs for monitoring, debugging and production support, and everything is repeatable and version control. So Terraform state will be like this. So Terraform code will be like this: main.tf, aks.tf, acr.tf. So it will create for each service, it will create .tf file, and same code can create dev, test and production. So just change the variables, it will run that all. So this is important because without Terraform, we have to click the portals and someone forgot that what they changed. So environments become inconsistent. So using this Terraform, so portal changes are overridden. So we will have something like a visual code. So what we did, what we are going to do. So everything will be under our control, and environment are consistent, so we can keep all environments same for AKA setup, networking and security rules. And only the size will be different. For production we will have different sizes and scales and cost. And easy disaster recovery. If Azure region fails, so Terraform will apply infrastructure, recreate same AKAs, same ACR, same databases, and recovery time will be in minutes, not days. And what is AKS here? So AKS is a Azure managed Kubernetes service. It runs your Docker microservices, keep them alive, scalable and reachable. ACR stores our Docker images and AKS will run our Docker images. AKS deployment. So what happens? Each service is deployed separately to AKS. Deployment, services, configure mapping and secrets. So services run in a microservice namespace. So AKS deployment per service. So this is the step about how each microservices run independently inside AKS. So what happens actually? So for each microservices, product, order, user and etc. So we need to deploy them separately like a Kubernetes objects. So no shared deployments, no tight coupling. So deployment. So what is it? Defines which image, how many replicas and update strategy. So example, so images we have product service 1.1.0 and replicas 3 we have and rolling update enabled. So AKS ensures required number of ports are always running, old ports are replaced safely during updates. So to be more clear, so AKS is like just a system that keeps our app running all the time. That's it. Everything else exists only to support this idea. For example, a real-time hotel example. So we have a hotel building, so that is AKS cluster, and we have floors, so that is what's nodes, that means VM, virtual machines, and we have rooms, so that's here called ports, and the guest means your app, the container. So multiple rooms for same guest type, that is called replica. Multiple rooms that is for the same guest, that is called replica. And the reception desk is like a service. So now in term wise we will see one by one. So we know AKS, Azure managed system that runs our apps 24/7 and scales and restarts it if it is crash. So we don't need to manage servers manually. So that's why we need a Azure Kubernetes service. And cluster, so meaning the whole AKS setup, like the entire hotel. And node, so an Azure virtual machine inside AKS. So AKS has multiple nodes. If one fails, other handles the traffic, like that. So pod, so that means a wrapper around our application. So one pod means one running instance of our application. So inside a pod we will have our Docker image container and networking, storage, like those things. Think like a room plus guest, I repeat. So inside a pod there will be our Docker container image, our Docker container, our .NET application, and the network for configuration and the storage things, like those things we will have. And a replica, so the meaning is how many copies of your app you want running. So something like 3 copies, 4 copies of our .NET application for more user supports. And deployment. So a manager that says which image to run and how many replicas, that means how many copies, and how to update safely. So we never create ports directly, deployment creates and manage them. Then service, a fixed address to reach your application. So why it's needed? Port comes and go and IP changes, so that's why. And namespace, we have a folder inside AKS, so we will have a microservices, keep things clean. So this is the very simple. And the flow AK, you see here AKS under that node, and a node can have multiple ports, and the port will have a container, a single port will have container, and if traffic increases, if the port will increase based on the requirement. And the next one, health props and rolling updates. So what happens is Kubernetes continuously checks liveness, if there is any service alive, readiness, can it accept the traffic. These two things it will check. During deployment, old ports or stay alive and new ports start, and the traffic shift gradually. I will show a visual small diagram here. So this is the traffic shift. So previously assume this v1, old is v1 and new is v2, and Kubernetes wait until readiness is okay, and then traffic goes to new port and old port will be removed. So this is how it will happen. If we have 3 ports, we will have v1, 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 and then first we will change this one to v2, then second one and third one. We will remove this v1 gradually. Ingress external traffic routing. So what happens here? External user hits ingress application gateway, and routing happens to products, orders, notification service. So why we need this? Because of single entry point, central routing and TLS, and easier security controls. Ingress is kind of a API gateway. So for a real-time example, we have a office building. On that main gate, so kind of main gate is our application gateway ingress, and security desk, that is called routing rules inside our ingress. And we have departments, that means microservices like product, order, like those things, and internal phone extensions, so that is K services. So visitors never walks inside directly or randomly. So what actually happens? External users make a request, and user will have no idea where to go. Then so request hits to ingress, the entry point, and ingress sits in front of AKS and checks the rules and forwards the request. And path based routing, so ingress rule says like this. So if it is /product, send it this to product service. Similar way order and notification service. So ingress decides that, and service forwards to ports, and product service load balances and send requests to one healthy port. And terms, so yeah, this ingress is a reverse proxy inside a AKS that routes external traffic. So like ng, ins, and API gateway or application gateway we can say. So and then we have application gateway, and these are Azure managed with load balancer, TLS termination, and WAF security rules. So this often used with AKS as well. And TLS, HTTPS. So Ingress handles the HTTPS, manages certificates, and service stays internal and simple. And why this design? So this is a single entry point. Client call this and not direct our services. And central routing. So we'll have central routing with HTTPS handled once and certification managed centrally, no duplicate configurations, and easier security controls. Why it's better than keeping a separate .NET API gateway like other service? So why this Ingress is better? So Ingress is better than a custom .NET API gateway because it handles Ingress is better than a custom .NET API gateway because it handles cross-cutting infrastructure concern at the time of platform level, not application level. Now let's prove it step by step. So what happens if you keep the .NET API gateway as a service? So architecture like, so you have a client, and in the client we have a .NET API gateway, a pod, and pod has product order or user services, and the problems will have, so we must have to scale our application. If traffic increases, gateway pod overload, so we must add our replicas and tune the threads pools and handle memory leaks and the infrastructure concern mixed with our app logic. And gateway becomes a single point of failure as well, might be. So gateway crashes, might sometimes it might crash if you keep manually, and we will have bad deployment and memory leak and the entire system goes down. So ingress failure are handled at infrastructure level, and the TLS and security logic is duplicated. So our .NET gateway must handle the HTTPS certifications, TLS renewal, and WAF break rules, rate limiting. So this is not business logic, but you are remaining it. And the deployment risk. So update gateway, redeploy the gateway, and risk of breaking routing for all the services. So ingress routing can change without touching app code. And higher latency. So client accessing gateway then services. So you should have extra hop, serialization plus auth logic. So ingress routing is a native and faster. And what happens with ingress and why it's recommended? So architecture like we have ingress and it's redirect to services. So it managing the platform scales it automatically, user native load balancing and optimized in C, faster and safer, and no single point of failure. So runs multiple replicas, actually the ingress runs in multiple replicas, and Azure managed API app gateway and health monitored by AKS. So infrastructure level reliability we have, and we have central TLS and security. So ingress handles HTTPS certifications, WAF rules, IP blocking, and rate limiting. So our services stay calm, focus only on business logic. Zero risk routing changes. So orders, we will have to new order services and change ingress rule, not app code. So no need to redeploy, no downtime here. And better separation of concerns. So ingress have routing, TLS, security, and services will have only the business logic. So this is a clean architecture. And when does a .NET API gateway make sense? So important thing, so API gateway is not always wrong. So we use the .NET gateway when we need request aggregation, protocol transformation, and custom auth logic. So backend for frontend like that. For example, mobile needs one API gateway API call, and gateway calls 5 services and returns combined response. So Ingress cannot do this. So at this time we might need this API gateway